I'm Anil Kumar, and in this video, we'll try to understand the basics about solving polynomial equations. And then in this playlist, we'll get into details. We'll have solution of polynomial equations given in factored form. We'll consider standard form of polynomial equations, factoring and then solving. We'll consider different domains of real numbers, rational numbers, complex numbers, even integers and whole numbers. And we'll have a lot of word problems in which we'll find area, volume, things like that, and solve polynomial equations. Now, before getting into all that, let us understand what solving polynomials mean. Well, basically, when we say solve a polynomial equation, then we are really looking for roots of the equation, or rather I should say zeros of the equation, right? So let's write down here what is the meaning of solve equation in general. So in this particular case, we have a polynomial equation which is given like this. So what does it mean? It means we need to find zeros of this equation. That means equate the equation to 0 and find the values of x which will give us 0. So that means we are looking for zeros of equation. That is what it means, right? Now, zeros could be real or imaginary, right? So we can have therefore real roots. Now real roots means x-intercepts. And we could also have imaginary roots. Now when we are talking about imaginary roots, we are talking about a domain which includes complex numbers. Just to give you a heads up, complex numbers are one where we have square root of minus 1 is equal to I. So, and in real roots, square root of minus 1 is not real, right? So that makes the difference. Well, when we talk about complex numbers, real roots are included in it, correct? So in short, that is what we are trying to say when we say solve polynomial equations. Now looking into all this, now you must have realized how important domain is, right? Now we'll again consider this polynomial, which is p of x equals to x minus 2 times x squared minus 3 times x squared plus 1. And let us look into solution of this polynomial in different domains. So let's begin with domain of integers, for example. So let us say x belongs to integers, which we normally represent by letter z or by I, right? So x belongs to z or I, or set of integers. In that case, what is going to be the solution of this equation? So in that case, solution is of course equating the equation to 0. So we'll say p of x is equal to 0, which is actually x minus 2 times x squared minus 3 times x squared plus 1. Now, to find the solution, these are all the factors. If they are 0, then we'll give product of 0 by anything is 0, correct? So we have to equate each factor to 0 to find the solution. So we'll equate the first one, which is x minus 2 equals to 0. We get x equals to 2, and that is the integer, so that becomes a solution. Then we equate x squared minus 3 equals to 0. We get x, let me write x equals to, we'll bring 3 here, and because it is square, we'll do square root, and whenever we do square root, we write plus and minus. Okay, then we will equate x squared plus 1 equals to 0, and here we get x squared, let me write, equals to minus 1. Now you know x squared cannot be negative 1 in real numbers, even in integers, right? So I'm just giving you a general solution first, and then we'll jump into conclusions. So from here we say, well, x is equals to plus minus square root of minus 1, which is indeed plus minus I, right? So these are the solutions. But now if you see set of integers, then in the set of integers, the only solution we have is x equals to 2. Since x equals to plus minus 3 is not an integer, It cannot be written in the form of a fraction, nor is plus minus I, correct? So the only solution here is x equals to 2. Do you get it? So it has only one solution in this set of integers. I hope you appreciate that part, right? Now let us do when x belongs to real numbers, for example. So if say x belongs to real numbers, that means R. In that case, what solutions can we have? Now x equals to 2 is a solution, and x equals to plus minus square root 3 is a solution in set of real numbers, but not x equals to plus minus I, correct? So we have two solutions here, and we say x is equals to 2 or x is equals to plus minus square root 3. So basically we have three solutions, 2 plus square root 3 and minus square root 3. Now if we have the same equation and we are considering set of complex numbers, see, right? In that case, what solutions do we have for the same equation? Well, in that case we have solutions as x equals to 2, and we can also write in one statement which is like plus 3 minus 3, so becomes 3, and also plus minus iota, the imaginary number. So in this case we have 5 solutions. Do you see that? Same equation. So depending on the domain, our answers are going to be different. So when you are solving polynomial equations, you have to really understand in which domain you are solving the equation, correct? At times, we may even solve it graphically, correct? So let me provide you a graphical solution here, right? So, so what we have here is kind of like this. In this case, the real roots will be represented on the graph. So when you say x minus 2, that means x equals to plus 2 is a solution, right? And square root of 3 is kind of 1.7 something. So it is less than 2. So it will be somewhere here and here, correct? So these are your real roots, correct? And the coefficient is positive. That means the right side is up. So when right side is up, then we have the, and these are all linear for us. So we'll have kind of graph which goes kind of like this, right? You can find the y-intercept. If you place x equals to 0, you get y-intercept as 6, correct? 3 times 2. So that means, let me write p of 0. When I substitute 0 here, I get what? 0 minus 2, 0 minus 3 times 0 plus 1, which is indeed equals to plus 6, minus 3 times minus 2, right? So that means we have a graph which is kind of, let me sketch in a different ink here. Okay, let me take green color. So we have a graph which is kind of, let me just draw one here, right? I know this is not going to be kind of like this. It will have some complex root somewhere else, right? Where plus minus I, so it will have a clink somewhere else, which I have not really shown. I should have shown. Okay. Anyway, so it is not exactly like this because of the complex root, which I'm not able to show it at present to you. Okay, in any case, we have a graph which is kind of like this. Okay, so the real roots are represented on the graph, which we can get, but the complex root is not shown on the graph because this graph is on the real domain, right? So when we talk about a graph, we are always looking for real roots. Remember that part. So this is a polynomial p of x, correct? And we can write down our roots, which are in this case minus plus 2 plus minus square root 3, right? And this point we found as 6. So when we are solving polynomial equations, we could do algebraically or we could also do graphically. You can use graphing calculator to find solution, but normally graphical solutions may not be very accurate, right? So we get an estimate from graphs. Now I hope with this we can understand when we talk about solving polynomial equations, we really mean what makes that polynomial equation 0. So we are looking for zeros. Now these zeros could be real or imaginary. Now it really depends on the domain in which you are working. If you are working in the domain of complex number, then you should report all the zeros as we have done here. There are 5 solutions. But if you are working in the domain of real numbers, then the answers will be only 3, which are 2 plus square root 3 and minus square root 3. But in case you are working in the domain of integers, for example, then square root 3 is not an integer. So your only solution will be x equals to 2 as we took here. So with that, we'll begin this chapter and do some questions. Thank you and all the best.